In this section, we will be working with linear equations in two variables. Now, a linear equation is one that relates an input and an output variable in such a way that it defines the points on a straight line, thus the name linear equation. Now, there's a couple of forms of linear equations that we will be working with in this class. The first is what we call slope-intercept form, and it takes on the form y equals mx plus b. X is the input variable. Y is the output variable. M and B are constants, and we'll learn more about those a little bit later. You can also see a linear equation written in what we call general form or standard form, and it looks like this: ax plus by equals c. Here again, x represents the input, y represents the output. And all of the ordered pairs that come out of this equation, all of the xy ordered pairs, define the points on a straight line. So looking at example 1, we have a linear equation in slope-intercept form, y equals 2x plus 3, and we're asked to verify that the ordered pairs below satisfy this equation. In order to verify, all you need to do is plug in. Here we have the ordered pair -2, -1. Here the -2 is x, the -1 is y. So in our equation we have y equals 2x plus 3. I'm going to replace y with -1 and x with -2. So I have -1 equals, copying down the 2 and replacing x with -2. Plus 3. And then working out the right-hand side, we have -1 equals 2 times -2 is -4 plus 3. -1 equals -4 plus 3 is -1. So it works. -2, -1 is a solution to this linear equation. It is going to be a point on this line. Doing the same thing with the ordered pair 0, 3, we have y equals 2x plus 3, replacing the y with 3 and the x with 0. We have 3 equals 2 times 0 plus 3. So 3 equals 2 times 0 is 0. So we have 3. And it works. So the ordered pair 0, 3 is also a solution to this equation. Next, we have the ordered pair 1, 5. So y equals 2x plus 3, replacing the x with 1, the y with 5. So we have 5 equals 2 times 1 plus 3. 5 equals 2 times 1 is 2 plus 3. 5 equals 2 plus 3 is 5. So it checks. Now on the graph below, I'm just going to plot each one of these ordered pairs, and you'll see that they do fall on a straight line. So here is the point -2, -1. Down here, I'm just going to label this -2, -1. Then we have the point 0, 3. That'll be right here. There's 0, 3. And 1, 5. 1, 5. And I'm just going to connect these points with a straight line, as straight as I can get it. And this is the graph of the linear equation y equals 2x plus 3. Every single point on this line is a solution to this equation. In example 2, we have a linear equation in standard form, 3x plus 2y equals 6, and we're asked the same thing. Verify that these 3 points are solutions to this equation, and then plot them and see that they do fall on a straight line. So starting with this first one, -2, 6, we have 3x plus 2y equals 6. Replacing the x with -2, the y with 6, we have 3 times -2 plus 2 times, replacing the y with 6, equals 6. Working it out, 3 times -2 is -6, plus 2 times 6 is 12, equals, just copying down the 6 on the right-hand side, -6 plus 12 is 6, equals 6. So it checks. For the next one, we have the ordered pair 0, 3. So copying down the equation, 3x plus 2y equals 6. Replacing the x with 0, the y with 3, and then we're just going to see if it works out. 3 times 0 is 0, so that's 0, plus 2 times 3 is 6, equals 6. 0 plus 6 is just 6, so we have 6 is equal to 6, which is true. For this last one here, we have the ordered pair 2, 0. So copying down the equation, 3x plus 2y equals 6. So 3 times, replacing the x with 2, plus 2 times, replacing the y with 0, equals 6. 3 times 2 is 6, plus 2 times 0 is 0, equals 6. So again, we have 6 is equal to 6, and it checks. All right, now noticing these two ordered pairs, 0, 3, without even looking at the graph, because there is a 0 in the input, we know that this is going to be the vertical intercept of the graph. And looking at this the same way, for this ordered pair 2, 0, 0 is the output, so we know that this is going to be the horizontal intercept of the graph. So plotting these points, we have the ordered pair negative 2, 6. That's going to be right about here on the graph. There's negative 2, 6. The next one is 0, 3. So that'll be right about here. And the last one, 2, 0. Right there. 2, 0. And plotting these with as close to a straight line as we can get here. There we go. That is the graph of this linear equation.